Hello there, and welcome to Sleepy Cosmic Podcast, where we wander beneath velvet skies following ancient light on its unhurried path through time. If this kind of quiet wonder helps you rest, I'd be grateful if you tap like or subscribe. No pressure at all. And if you'd like, tell me where you're listening from and what time it is there tonight. Now, dim the lights, maybe turn on a fan for a soft background hum, and let's ease into tonight's journey together. We begin with a blur. The first clear look at an interstellar visitor called 3I Atlas was anything but clear. When the European Space Agency released its images, what people saw was a small white smudge against the deep Martian night, a faint shape that might have been anything. The world had waited for this, 7 orbiters poised, countless hopes resting on one frame that would reveal what this object truly was. Instead, it resembled a snowflake falling through fog. But behind that disappointing blur lies a quiet truth about how difficult it is to see across space. Light is a patient traveller, but it weakens as it spreads, thinning into whispers by the time it reaches a camera's sensor. ESA's orbiter was designed to study Mars, not to photograph a dark wanderer 30 million kilometres away. Each pixel in its field of view covered hundreds of kilometres of space. Even the most brilliant comet at that distance would shrink to a single pale dot. We often imagine that high technology guarantees clarity, yet astronomy is built on inference, on patterns teased from noise, on signals barely above the background hum of the universe. The Hubble Space Telescope, floating above Earth, can resolve a galaxy's arms, but even it blurs the faintest stars into points. The Webb telescope peers through infrared wavelengths, where light has stretched over billions of years, yet what it reveals often looks like soft smoke, not crystal shapes. Sharpness is not the same as truth. Sometimes the cosmos hides its detail on purpose. Astronomers measure brightness in magnitudes, a scale that feels almost poetic. Each step on that scale means a change in brightness by a factor of about 2.5. The faintest thing visible to the naked eye is magnitude 6 under a dark, moonless sky. 3 Atlas, by contrast, hovered near magnitude 16, thousands of times dimmer, its photons arriving one by one like tiny raindrops on a vast roof. To see it clearly would require long exposures, stacking, calibration, and a bit of faith. Still, the release of those fuzzy frames sparked something beyond technical critique. It was emotion, disappointment mixed with suspicion. How could a machine orbiting Mars, capable of seeing surface rocks in crisp detail, produce something so featureless when pointed outward? The answer quietly is geometry. The camera was built to capture bright terrain beneath, not faint sky beyond. Its optics and detectors were tuned for contrast, not for shadow. When they looked into deep space, they saw their own limitations reflected back. We might compare it to listening for a whisper with ears made for thunder. The faint signal was there, but wrapped in its own silence. When light passes through an instrument not meant for such subtle work, diffraction softens it, photons scatter off internal glass, and the image blooms into haze. That haze is not deceit, it is physics, the natural blurring of distant motion. Yet public imagination doesn't rest on calibration curves. It hungers for revelation. The blur became a mirror where people saw what they wished to see. Some a simple comet, others an engineered mystery. But what if that ambiguity is the real story? Astronomy often begins with smudges. The Andromeda Galaxy was once catalogued as a nebula, a cloud within our own Milky Way, until a century later someone measured its redshift and realised it was a universe apart. Every blurred image is an invitation to ask finer questions. Perhaps the blur of 3I Atlas is not a failure but a threshold, one more veil between certainty and curiosity. When we look into that indistinct spot, we glimpse the limits of perception itself. Light travels unbroken for billions of kilometres, then dissolves in a pixel's noise. Between those two extremes lies everything we know about seeing. The European Space Agency's scientists likely knew how faint the outcome would be. They pointed their camera anyway, because even a blur is data. From its motion across the background stars, they could refine the object's orbit. From the brightness curve, they could estimate its activity, whether dust or gas streamed from its surface. It may look unimpressive, yet it anchors equations that describe its path through our solar system. To the eye, a ghost. To the mind, a compass. When you think of it that way, the faintness becomes beautiful. In the quiet pixel lies an entire journey from another star, moving faster than any comet ever catalogued. Its light may have reflected off crystals of ice older than Earth itself, and now that ancient dust rests inside a handful of blurred photons stored on a silicon chip orbiting Mars, a memory captured in static, waiting for meaning. As we drift through this thought, imagine standing in the control room when those images first appeared. Screens glowing, engineers leaning forward, the first glimpse resolving, and then the silence as they realize it's all haze. Perhaps a sigh, perhaps laughter, perhaps only the hum of cooling fans. Disappointment, yes, but also wonder that we can even see at all across 30 million kilometers. That light obeys us just enough to whisper back. The universe has always been a dialogue between expectation and humility. We build instruments to sharpen our view, but what we discover most often is our own softness, and sometimes, in that softness, truth hides more comfortably than precision would allow. So, let us keep the blur. Let it remind us that mystery isn't failure, it's invitation. When the stars smudge, when the data trembles at the edge of meaning, that is the point where curiosity begins to breathe. 3i Atlas gave us no crisp revelation, only a luminous fog across blackness. But in that fog, we can trace the quiet persistence of light and the patience of those who follow it. The silence came next. When NASA's high-resolution Mars orbiter should have been releasing its own crystal-clear view, there was nothing. No press release, no data drop, no explanation, only a single line on an agency status page noting that updates were delayed because of a government shutdown. For a while, that phrase hung in the air like a faint echo. Delayed, not cancelled. But the silence stretched, and people began to notice how still the world can become when bureaucracy meets the cosmos. The orbiter in question carries one of the most remarkable eyes ever built for another world. It can resolve objects the size of a coffee table on Mars from hundreds of kilometers above the surface. Its mirror is finely polished, its detectors cooled and shielded from radiation that would blind lesser instruments. It was designed to watch dust devils whirl across ancient craters, to catch the glint of rover wheels in sunlight, to trace the history of water in mineral scars. Yet during the most extraordinary event within reach, an interstellar object passing near its orbit, it remained mute. Silence in science can mean many things. It can mean caution, or calibration, or politics. Sometimes it is as simple as human timing. The right people furloughed, the wrong servers paused. The machines keep working, but their data sit unread, their signals bouncing into temporary vaults. From a distance, though, that pause looks deliberate. The human mind fills the gap with stories, and each story grows in the absence of official words. There is a strange symmetry between political stillness and cosmic stillness. Both feel vast, slow, and slightly unreal. In deep space, silence is not emptiness. It's the natural state of things. No air to carry sound, no medium for vibration. Every spacecraft we send must speak through radio waves, turning electrical pulses into meaning across millions of kilometers. When those messages stop, even briefly, it feels as if the universe has closed its mouth. Astronomers often compare waiting for new data to waiting for dawn. You know light will come, but not when. teams continue their simulations, refining trajectory models, whispering over telemetry that arrived before the shutdown. Somewhere inside NASA's data pipeline, bits of 3i Atlas might already exist, stored in raw binary, awaiting review when work resumes. But until someone officially confirms that, the images remain a kind of Schrödinger's data, both real and withheld. It's worth remembering that even the greatest observatories rely on fragile human systems. A telescope's mirror can be flawless, its orbit stable, but it still depends on budgets, schedules, and quiet rooms full of people to interpret what it sees. When the people step away, the silence of space echoes through the silence of administration. In that gap, the story takes on a rhythm of absence. Scientists check in from home, writing notes they cannot officially send. Amateurs speculate, comparing the agency's calm to the stillness before a storm. The truth is probably ordinary: delays, bureaucracy, caution. But in a world accustomed to instant images, even ordinary silence feels mysterious. Silence, after all, is powerful. It shapes what follows, just as a rest in music makes the next note feel alive. Every pause in communication gives birth to new theories, and in the vacuum left by NASA's missing voice, thousands of others rushed to speak. Some said the cameras had failed, others whispered of hidden findings too disruptive to share. Yet through all that speculation runs a deeper theme: our unease with not knowing. In a culture of constant signals, silence feels like a glitch rather than a choice. If we step back, though, that quiet might teach something profound. In radio astronomy, researchers often speak of the deep listen. When the instruments go still, they tune their own hearing instead, learning to distinguish between interference and the faint pulse of a distant quasar. Maybe NASA's pause was a kind of enforced deep listen, a moment to remember that knowledge requires intervals of uncertainty. There's also the simple fact that silence is data in its own way. Every gap between updates records the tempo of human systems, the fragility of exploration itself. We're used to imagining space exploration as a seamless stream of progress, but in reality it moves like a heartbeat. Periods of action punctuated by long waits for recovery. A spacecraft doesn't just send images, it sends patience, stretched across time. Somewhere above Mars, the orbiter continued its orbit, cameras dormant but functional, tracing the same ellipse day after day. Its solar panels caught sunlight that left the sun 8 minutes earlier. Its antenna whispered telemetry to ground stations that could only listen, not interpret. Even in bureaucratic silence, physics goes on untroubled. Gravity doesn't wait for policy to resume. If we imagine standing outside that loop, perhaps in a silent control room, lights dimmed by budget constraints, we might feel what the engineers feel, a mixture of frustration and awe. The machine they built keeps working flawlessly, obeying laws older than the institutions that fund it. The gap between human pace and cosmic pace becomes obvious. Our systems flicker on and off with elections, storms, or strikes. The planets simply turn. When the orbiters fall quiet, we're reminded of our smallness in that turning. We may build instruments that see beyond our world, yet they are tethered to our economies, our politics, our calendars. Space doesn't care about deadlines. It moves in centuries, not fiscal years. Perhaps that's why silence feels unsettling. It measures the distance between our urgency and the universe's calm. There's a term in astronomy called light-time delay. It describes the gap between an event's occurrence and our ability to perceive it. When you look at Mars tonight, you see it as it was about 15 minutes ago. Everything in space carries this built-in silence of delay. We never see the present, only the past catching up. In that sense, NASA's quiet moment fits the universe perfectly. We're always waiting for light to arrive, so when people grew impatient with the missing images, perhaps they were only feeling that old cosmic truth more keenly, that we are creatures of immediate senses living in a delayed universe. Sometimes we must let the silence breathe before meaning can emerge. The stillness of NASA's cameras is, in its own way, an echo of space itself, vast, necessary, and full of the potential to speak again. Far beyond the silence of one agency, another quiet descended, a global hush that spread like a slow shadow across every observatory pointed toward Mars. China's Tianwen-1 spacecraft, orbiting high above the red planet, said nothing. The United Arab Emirates' Hope probe, usually eager to share images of Martian dust storms and blue dawns, released no data either. Even the European Space Agency, having offered its blurry images, refused to elaborate. It felt as though the whole sky had agreed to hold its breath. At first, people assumed coincidence. Different nations, different missions. Surely they weren't all seeing the same thing. Yet the timing aligned too perfectly. Each orbiter had an unobstructed view of Three-Eye Atlas during its closest approach. Each had cameras tuned to different wavelengths, capable of revealing structure invisible to the human eye. And still, the data stream stopped at once, like instruments in an orchestra resting on the same measure of silence. Perhaps it was ordinary caution. Space agencies guard their raw data carefully, releasing results only after calibration and review. But this wasn't just data. It was a moment of shared anticipation, a chance for collaboration beyond borders. For decades, space science has thrived on transparency. The orbits of comets, the spectra of distant galaxies, the maps of Mars, all are published, peer-reviewed, and publicly archived. Silence of this scale felt unfamiliar, even unnatural. Political gravity pulls invisibly, much like the cosmic kind. Beneath the shared language of science, every agency answers to its own government, its own ambitions, its own unspoken rules. Sometimes those rules converge into stillness, not censorship perhaps, but a form of waiting, each side hesitant to speak first, to reveal what it knows or what it suspects. After all, data is power, and power prefers quiet before revelation. The cosmos itself has long been a theatre of diplomacy. The first images from the moon carried both flags and handshakes. Space cooperation has always balanced wonder and politics, joint missions, shared instruments, and mutual curiosity paired with strategic restraint. So when all these orbiters fell silent at once, it was easy to imagine unseen conversations unfolding behind closed doors, scientists debating how much to disclose, administrators weighing timing against consequence. The pattern echoed deeper histories. During the Cold War, both superpowers occasionally detected unusual signals, pulses, bursts, or luminous trails, then waited weeks to announce them, fearful of what they might mean. One country's anomaly was another's advantage. Even now, half a century later, remnants of that reflex remain. A celestial discovery can ripple far beyond the telescope that captured it, into politics, economy, and belief. Sometimes silence feels safer than explanation. It's possible, too, that nothing extraordinary happened at all. Perhaps each orbiter's instruments faced technical limitations, their sensors overwhelmed by brightness, their focus calibrated for the Martian surface, not a faint visitor. Maybe the scientists simply wanted more time to refine their findings before public release, but absence always invites imagination. And imagination fills the gaps faster than truth can catch up. We are social creatures living in a vast, indifferent universe. When communication ceases, our minds reach for connection, weaving narrative threads until they touch. That's how myths begin, not from deceit, but from the human instinct to make silence meaningful. In the old days, comets were omens because they arrived unannounced. Now, even in the age of satellites, their mysteries still awaken that ancient reflex, the sense that the heavens might be trying to tell us something. The global hush around Three-Eye Atlas revealed another truth. Science is not separate from culture. Our telescopes may orbit planets, but our expectations orbit trust. When that trust falters, every missing image becomes a cipher, and trust is fragile because space itself is so remote. No one can step outside and see what the orbiters see. We depend on light translated through machines, through institutions, through interpretations. When those translations pause, uncertainty grows louder than data. Even so, there's a strange beauty in shared silence. For once, humanity's scattered instruments around Mars, all those fragile emissaries, found a common rhythm of restraint. From different nations, in different languages, their transmissions quieted to the same background hum of deep space. Perhaps it wasn't coordination born of secrecy, but coincidence born of cosmic timing. Maybe the object itself, its motion, its position near the sun, simply outpaced our capacity to observe. Silence then was not conspiracy, but humility. Space has a way of reminding us that timing matters more than intent. An object moving tens of kilometers per second can pass through an observational window in hours. If clouds or glare intervene, that window closes. By the time signals are processed, the moment is gone. Every mission is a race against orbital geometry, against the relentless motion of worlds. Sometimes the universe doesn't hide. It just moves too quickly for us to follow. Still, it's difficult to shake the feeling that something deliberate lingers beneath the quiet. Silence synchronized across nations feels unnatural, even poetic. It suggests not only a missing signal, but an agreement, spoken or unspoken, to let the unknown remain unknown a little longer. Maybe that's what maturity looks like in cosmic terms, not rushing to explain every anomaly, but accepting the need for collective pause. When we look at that hush with softer eyes, it becomes almost tender. Here were machines circling another planet, holding their peace beneath the same stars that have watched civilizations rise and fall. Here were humans, divided by language and history, sharing a single bewilderment. Whether by design or by accident, the world looked upward together, waiting. If there is a pattern in that waiting, perhaps it mirrors the cosmos itself. Vast systems suspended in equilibrium, galaxies turning silently around dark centers. The universe rarely shouts. It whispers, it pauses, it lets us lean closer. And in that pause, between signal and silence, between one nation and another, lies the fragile thread that keeps science human. While the orbiters circled Mars in their synchronized quiet, the Earth itself was still awake. Across rooftops, balconies, and mountain observatories, amateur astronomers turned their telescopes skyward, tracing a faint path across the stars. What professionals hesitated to show, the curious tried to capture, and in that fragile space between citizen science and wonder, new images began to emerge, small, imperfect, but alive with detail that official data lacked. In Portugal, an observer who called himself Dobsonian Power adjusted a modest solar telescope in his backyard. It wasn't built for deep space. Its filters were designed for the blinding surface of the sun, not for something dim and wandering 30 million kilometers away. But curiosity doesn't always wait for perfect equipment. He aimed, steadied his hand, and captured a faint glimmer moving against the starfield. A patch of light shaped not like a sphere, but like something angular, folded, almost architectural. He processed the image carefully, adjusting contrast, subtracting noise, stacking exposures, and then he stopped, unsure whether what appeared on his screen was real or illusion. He posted it quietly online. No headline, no sensational claim, just a single caption. What on earth is it? Within hours, the picture spread across astronomy forums and social media feeds. Some saw structure, dark ribs perhaps, or a lattice under translucent mist. Others saw noise and wishful thinking, the brain's habit of finding meaning in randomness. Pareidolia, they called it, the same quirk of perception that lets us see faces in clouds or animals in constellations. But the debate that followed wasn't hostile. It was alive, buzzing, filled with both skepticism and awe. People compared the amateur's capture to professional comet images, to telescope artifacts, to known camera distortions. The threads ran long into the night, voices from every time zone overlapping like distant radio stations. No one agreed on what the picture showed, but everyone seemed grateful that someone had tried. In that way, backyard astronomy became a quiet rebellion against the silence above Mars. While agencies measured their words, ordinary people looked for light. It's easy to forget how much of astronomy depends on such devotion. For centuries, discoveries have come not from grand observatories, but from lonely watchers with notebooks, patience, and clear skies. The planet Neptune was first predicted through mathematics but confirmed by an independent observer using a simple telescope. The discovery of variable stars, supernovae, even the first observations of comets, all were born from amateurs who refused to look away. In modern times, digital cameras and software have turned backyard observers into contributors to professional science. Networks like the Minor Planet Center and the American Association of Variable Star Observers rely on thousands of such volunteers to track moving objects, measure brightness, and refine orbits. Every small image adds to a larger tapestry of understanding. But 3i Atlas seemed to stir something different, something emotional. Perhaps it was the timing, a world weary from uncertainty, a public hungry for wonder that hadn't been curated. Perhaps it was the thought that an object from another star could be witnessed by human eyes from an ordinary street. Each new frame, each shaky video clip, felt like a message from the cosmos delivered directly to whoever cared enough to look. Of course, the debate soon split along familiar lines. Some declared the angular shapes evidence of technology, perhaps remnants of an artificial probe cloaked in dust. Others dismissed the idea as fantasy, explaining the geometry through diffraction patterns or oversharpened pixels. Between those extremes lay a quieter middle ground, the observers who simply admitted they didn't know. That humility, rare on the internet, gave the conversation its soul. It's fascinating how often science begins with uncertainty rather than answers. Every theory starts as a question framed by wonder. Even the professionals who later build consensus start from the same place as those amateurs, a moment of quiet confusion under the stars. That confusion, if tended with care, becomes discovery. One astrophysicist later remarked that the most honest words in the field are not eureka, but that's odd. Oddness is the compass of curiosity. When an image doesn't fit, when data refuse to behave, we are reminded that the universe is under no obligation to conform to our expectations. Maybe that's why these blurry, home-captured photographs resonated so deeply. They reminded people what science feels like before it hardens into certainty. Beyond the specifics of 3i Atlas, there's something timeless about those backyard telescopes. They embody a truth older than institutions, that the night sky belongs to everyone. You don't need clearance or funding to gaze upward. The light that left a comet or an alien star reaches you freely, crossing time and vacuum to fall upon your eyes. Even when data are withheld, the cosmos remains open to patience. We might imagine Dobsonian power, after posting his image, stepping outside again to look at the same patch of sky. Perhaps he felt doubt creeping in, wondering whether he'd misfocused or mistaken a star. Perhaps he smiled at the absurdity of it all, a man with a solar telescope photographing interstellar mystery from his garden. But that too is part of the beauty. Astronomy has always been an act of disproportion, small beings measuring infinite things. When official voices fall silent, these quiet observers become our link to wonder. Their images may not be perfect, but they carry something sharper than resolution, sincerity. Each blurred photon they capture says, "We are still watching." And maybe that's what matters most. The universe does not reward only precision, it rewards attention. Whether through a billion-dollar camera orbiting Mars or a backyard lens catching stray light between clouds, each observation declares the same gentle defiance. That mystery deserves witnesses. In a time when science can feel distant and controlled, the hum of those small telescopes brought humanity closer to the cosmos again. Through their imperfect eyes, we saw something that institutions could not provide. A reminder that discovery is not a privilege, but a shared act of looking up. So the global hush was broken not by governments or space agencies, but by starlight scattered across a backyard sensor, by a question typed into a comment box, by the simple courage of curiosity. And under that same velvet sky, more people began to look. When the first amateur images spread across the internet, the arguments that followed carried their own kind of orbit. They circled endlessly between skepticism and belief, between science and imagination. It was here that an ancient pattern revealed itself again, the tendency of human minds to find meaning in noise. We saw it when radio static first sang through early antennas, when blurred photos of distant worlds seemed to reveal canals, faces, or monuments. And now, in the digital glow of the 2020s, we were seeing it once more. Pareidolia is a quiet trick of the brain, the way neurons seek order where chaos reigns. It's why you can look at the side of a mountain and see the outline of a sleeping giant, or glance at the moon and notice the shape of a rabbit. Our species evolved to recognize patterns quickly. It kept us alive when danger hid in leaves and shadows. But when that same instinct peers into cosmic static, it doesn't always know when to stop. For astronomers, distinguishing pattern from artifact is the hardest kind of discipline. Images of deep space are always imperfect, marred by noise, scattered light, and the heartbeat of the instruments themselves. When you magnify a faint target, you also magnify the ghosts of every vibration, every thermal fluctuation, every electronic hum inside the detector. Those ghosts often arrange themselves into shapes the mind can't help but interpret. Lines that look like panels, points that resemble running lights, or angles where only probability should exist. The arguments that bloomed around Three-Eye Atlas followed a script as old as astronomy. Some claimed the shapes were evidence of artificial origin, proof that the object was a vessel rather than a comet. Others countered with examples of similar illusions, diffraction spikes that make stars appear cross-shaped, streaks from cosmic rays striking camera sensors, or stacking errors that produce phantom geometry. The debates grew technical, then emotional, then philosophical. Each side was really arguing not about pixels, but about belief in randomness or in purpose. There is an odd comfort in that tension. To argue about what we see is to admit that we're still capable of wonder. The line between science and imagination isn't a wall but a horizon, always distant, always drawing us forward. Every true discovery begins as something that looks impossible. Before Saturn's rings were understood, they were mistaken for moons. Before galaxies were recognized as separate from the Milky Way, they were called spiral nebulae, small swirls of confusion. Even pulsars, when first detected in the 1960s, were labelled LGM-1 for little green men because no natural explanation seemed adequate. Perhaps we need pareidolia as much as we need skepticism. Without the courage to mistake noise for signal, we might never notice new patterns waiting to be explained. Every illusion teaches us something about our instruments, our biases, our hunger for connection. It's no coincidence that some of the best astronomers have been both dreamers and doubters, capable of believing two contradictory ideas at once until data choose between them. The history of observation is full of such moments. In 1877, the Italian astronomer Giovanni Schiaparelli looked through a telescope and thought he saw canali, channels, crisscrossing the Martian surface. The word was mistranslated into English as canals, and suddenly Mars was alive with imagined civilizations. Writers, artists, and even scientists built whole theories around those phantom lines. Decades later, when better optics revealed nothing but dust and rock, the illusion faded, but the dream it sparked never quite vanished. It pushed humanity to send probes, rovers, and orbiters, all born from a mistake that made people care enough to look closer. Maybe 3i Atlas will prove to be another such catalyst. Whether it is comet, relic or illusion, it has already reminded millions what it feels like to ask without certainty. The images might be blurry, the shapes debatable, but the act of looking, really looking, is the truest expression of science we have. Even now, researchers try to quantify the human tendency to see structure in randomness. They generate artificial star fields, inject faint patterns, and test how quickly observers claim to notice alignment or symmetry. The results are striking. Most people perceive order long before it truly appears. The cosmos seems empty of design, yet our minds decorate it anyway, stitching constellations from unconnected points. We can't help but make meaning. It's our way of staying awake in an indifferent universe. And yet sometimes the patterns are real. Sometimes what looks like illusion turns out to be discovery. The cosmic microwave background once seemed like noise until it was recognized as the afterglow of the Big Bang. The first gravitational wave detection was buried under months of statistical analysis before its faint ripple was confirmed. Every false start teaches us how to listen better. Every imagined shape makes the next real one easier to recognize. So perhaps the arguments swirling around those backyard photographs are not distractions, but rehearsals. They prepare us for the next moment when the universe shows something we've never seen before. We will argue again, of course, we always do. But through that friction, clarity is born. Late at night, as debates cooled and screens dimmed, one could imagine those same observers stepping outside again. The air still, the stars unchanged, the faint arc of Mars glowing red above the horizon. Somewhere out there, 3i Atlas drifted silently, neither confirming nor denying anything, indifferent to our interpretations. Perhaps it knew, in whatever way objects can know, that mystery needs both believers and skeptics to stay alive. The universe, after all, has no obligation to be simple. It speaks in riddles of light and shadow, knowing that we will always try to read them. And in that act of reading, mistaken, hopeful, human, we find ourselves reflected back. Our minds, like telescopes, gather scattered light and shape it into meaning. Whether the shapes are real or imagined matters less than the quiet wonder that compels us to look again tomorrow. When the debates cooled and the images settled into archives, another kind of analysis began. One conducted not by people, but by machines. Researchers started feeding the blurry frames of 3i Atlas into artificial intelligence systems, letting algorithms do what the human eye could not. They wanted clarity, and AI seemed the best way to find it. But clarity is a tricky word. It promises truth, yet often delivers interpretation. These new programs didn't just sharpen, they imagined. They were trained on millions of astronomical images, each labelled and catalogued: galaxies, comets, nebulae, fragments of light. When shown a blur, they searched for patterns familiar to their experience, guessing what might lie beneath the noise. The result was stunning, sometimes unsettling. The haze resolved into forms that looked geometric, symmetrical, almost intentional. Edges straightened, curves balanced. The image seemed to whisper of design. Soon those machine-enhanced pictures spread online, accompanied by captions that spoke in tones of wonder or alarm. Some said the object resembled an artifact, a vessel cloaked in dust. Others saw the algorithm's touch for what it was, an artist's reconstruction, not a revelation. Still, it was hard to ignore the beauty of it. A pale structure suspended in darkness, its symmetry glowing faintly against the void. Even knowing it was computational guesswork didn't make it less mesmerizing. Artificial intelligence, after all, is only our newest mirror. It reflects not the universe, but our way of looking at it. When we ask an algorithm to see, we are really teaching it to dream within the limits of data. And like any dream, its visions carry fragments of truth mixed with fantasy. One astrophysicist called this process machine pareidolia, a system learning to hallucinate structure from probability. It's both tool and trap. In that sense, AI and astronomy share a strange kinship. Both deal in faint signals. Both try to extract meaning from chaos. The only difference is that astronomers use mathematics while machines use memory. One integrates over noise, the other recognizes patterns from the past, yet both are prone to overconfidence. When pixels align too neatly, the mind, human or artificial, wants to believe. There's a story from early image processing in the 1990s, when scientists first used deconvolution algorithms to sharpen Hubble's blurry images. The telescope had launched with a tiny flaw in its mirror, producing distorted pictures of stars. When they applied mathematical corrections, some images suddenly appeared to reveal features never seen before, shapes that looked like filaments, arcs, even dark centers that seemed too precise. Only later did they realize that many of those details were artifacts created by the software itself. In their hunger to recover truth, they had fabricated it. AI enhancement can fall into the same illusion. A convolutional neural network doesn't know the difference between a real edge and a statistically likely one. It fills in gaps the way a painter completes a memory. So when the processed 3i Atlas images revealed their strange geometry, it was hard to say what portion belonged to the cosmos and what to the code. Still, that uncertainty doesn't make the effort meaningless. Every act of interpretation, even flawed, pushes our understanding forward. In refining what we think we see, we learn more about what we can see. AI's reconstructions taught scientists about the limits of resolution, about how algorithms respond to noise, and about the biases embedded in their training data. They learned that when you train a system on round comets, it tends to make new comets round. When you train it on structured satellites, it finds structure everywhere. Perception becomes expectation encoded in silicon. But there's another layer, subtler still. AI has begun to reveal patterns invisible to our intuition, not geometric forms, but statistical ones. It can detect faint periodicities in brightness curves, correlations between colors and motion that human observers overlook. Sometimes it predicts behavior before telescopes confirm it. This is where machine perception ceases to be mimicry and becomes discovery. Maybe, in time, our artificial counterparts will see the universe differently, through lenses free of human myth. They might find order where we see only chaos, or chaos where we crave design. And yet, even that thought humbles us. Because if machines can dream of structure, perhaps the universe itself is one vast dream of probability, collapsing into form only when observed. Quantum mechanics whispers something similar, that particles exist as waves of possibility until attention pins them into being. In that view, the AI's hallucination isn't a flaw, but an echo. Our technology reenacting the same dance the cosmos performs every instant. Perception, creation, revision. Still, for now, the mystery of 3i Atlas remains unresolved. The official agencies dismissed the AI-enhanced images as unverified, urging caution. They reminded the public that noise can mimic meaning, that interpretation must wait for real data. But the images refused to fade from memory. They lingered like dreams one can't quite forget. Beautiful, fragile, and perhaps a little too symmetrical to ignore. Late at night, when the servers had cooled and the debates quieted, some scientists admitted to one another that they felt both fascination and discomfort. It wasn't that they believed the images showed anything artificial. It was that they reminded them how easily perception bends. Even with our finest tools, we see what we are ready to see, and readiness is not always the same as truth. So the machines kept analyzing, the humans kept watching, and between them stretched a silence filled with possibility. Perhaps someday, when better telescopes turn their eyes toward the traces left by 3 Atlas, we'll know which edges were real and which were the dreams of algorithms. Until then, the story stands as a quiet lesson about seeing, how every act of observation, no matter how precise, carries a little bit of imagination. In that balance between clarity and wonder lies the soul of astronomy itself. The stars are not merely there to be measured. They are there to remind us that seeing is never simple, and that every sharpened image, no matter how perfect, still begins with a blur. The stillness between signals did not last long. Only days after those AI reconstructions spread through digital space, a quiet rumour began to circulate within the scientific community, one that spoke of something impossible. An alleged insider from the European Space Agency claimed that 3i Atlas carried 3 anomalies no natural object could possess: nickel without iron, cold outgassing without heat, and a trajectory so precise it seemed aimed rather than flung. At first, it sounded like another online fabrication, the kind of whisper born from long nights and blurred screenshots. But the words were specific, and specificity has gravity. Nickel without iron. That phrase alone caught the attention of physicists everywhere, because in the furnaces of stars, nickel and iron are inseparable siblings. They form together in the same nuclear reactions, fused from the same collapsing cores of massive suns. Where you find one, you always find the other. Nature does not part them easily. To separate nickel from iron, you would need conditions no known star can sustain. A controlled refinement, a deliberate choice. On Earth, such purity is the mark of industry, not of geology. It's the kind of pattern that makes the scientific mind pause, not because it proves anything, but because it resists every known explanation. Astronomers have seen unusual ratios before, of course. Certain asteroids contain high nickel content, others low iron, depending on how they cooled after early collisions. But even in those rare cases, the two metals coexist. A total absence of one beside the other would be extraordinary. It would imply that 3i Atlas formed in a crucible unlike any other we've studied, or was altered long after formation. When such rumours emerge, scientists tread carefully. They know that chemistry in space can be deceptive. Spectral lines, the fingerprints of elements, can overlap, hide or shift depending on temperature, motion and instrument calibration. A missing line in a spectrum does not always mean a missing element. Sometimes it means noise, misreading, or light absorbed by dust. But sometimes, very rarely, it means that something genuinely unexpected is shining back at us. If the claim were true, it would touch the heart of cosmic alchemy. Because in stellar forges, the path from lighter elements to heavier ones stops at iron. Beyond that, fusion consumes energy instead of releasing it. Iron marks the end of a star's creative life, the point where collapse begins. To find nickel without iron would mean that the usual rules of stellar death had been rewritten. It would hint at processes we have not yet imagined, or at craftsmanship on a scale that defies analogy. In those whispered discussions, a question began to form, not, what is 3i Atlas made of? But, what kind of story could explain it? Some invoked exotic physics, magnetically fractionated ejecta, selective sublimation, or condensation in unusual magnetic fields. Others, more cautious, pointed out that the rumour itself might have been a misunderstanding. Perhaps nickel without iron referred not to absolute absence but to a skewed ratio. Science advances through such caveats, but even caveats can't entirely smother curiosity, because if one entertains the notion, even briefly, that an interstellar object could display such precise composition, the imagination begins to wander. Could it be debris from an ancient civilization's industry? The slag of a forge that worked beyond stellar means? Could it be the cooled skin of a machine? A fragment from something once alive in a way we do not yet understand? These are not claims, only questions. But questions have momentum. They move the mind as surely as gravity moves planets. The notion of impossible chemistry also resonates on a deeper level as metaphor. Human beings too are forged in unity and divided by choice. We separate what nature binds, refine what was once whole. Perhaps our fascination with the nickel-iron paradox mirrors our own search for meaning, our hope that somewhere in the vastness, someone else also learned to shape matter with intention. Still, most astronomers remained grounded. Until spectra were confirmed by independent instruments, there could be no conclusion. Science, at its best, is patient skepticism. But even the skeptics felt a twinge of wonder, because anomalies, even if they vanish under scrutiny, are the stepping stones of discovery. They remind us that the universe is still capable of surprise. Consider this. The entire field of exoplanet research began when a star's spectrum showed a wobble that didn't fit existing models. For decades, that wobble was dismissed as error, instrument drift, or data noise. Then one night in 1995, two astronomers confirmed it, an unseen planet tugging its star. From one anomaly came thousands of new worlds. Every revelation begins as an error we can't quite explain. So perhaps the leak about 3i Atlas was not a revelation but an early tremor of attention, a reminder that something just beyond our certainty still moves through the dark. Maybe the claim of nickel without iron will fade like static. Or maybe it will stand, quietly waiting for better instruments to prove it true. Either way, it has already served its purpose. It has made us look more closely. Late at night, deep in research centres across the world, spectral data flicker on monitors, thin lines of light on black backgrounds. Each spike, each dip, each ratio tells a story older than humanity. In those lines, the universe writes its autobiography, and sometimes it hides a secret between the letters. If 3i Atlas truly carries an impossible chemistry, we may not yet have the language to read it, but we can listen. Because even a rumour, when it concerns the stars, reminds us how much we still yearn to understand what glows beyond the reach of certainty. Not long after whispers of strange chemistry began to circulate, a second layer of rumour surfaced, one even stranger, more poetic, and perhaps more unnerving. It spoke of a cold fire around 3 Atlas, a faint outgassing visible to sensitive instruments but lacking the heat that physics demands. And it added that the object's course through the solar system was not merely smooth, but exquisitely precise, as though guided by intention rather than accident. Cold outgassing sounds impossible at first hearing. When comets approach the warmth of a star, sunlight sublimates their frozen volatiles, turning solid ice into jets of gas that burst outward, creating the glowing tails we see. Those jets are chaotic, uneven, pushing the nucleus slightly this way or that. Their chemistry betrays heat, friction, randomness. But the data attributed to 3i Atlas describe something gentler, steady emission without corresponding rise in temperature. No sudden flickers, no hotspots, just a calm halo, whispering outward as though the object breathed without burning. Physicists debated whether such a thing could exist. Some suggested exotic ices, perhaps nitrogen or carbon monoxide locked within porous minerals that vented gas under very little energy. Others mentioned piezoelectric reactions, mechanical stress within crystalline lattices releasing faint plumes without visible flame. And then, more daringly, a few proposed electrical mechanisms, low-temperature plasmas, glow discharges moving like aurorae across the surface of a frozen world. Nothing in those ideas violated physics, yet together they hinted at a realm of behaviour barely explored. The second anomaly, the perfect trajectory, was harder still to explain. Interstellar objects normally enter the solar system with random inclinations, tumbling like forgotten debris from the galaxy's outer stream. But 3 Atlas moved in a plane nearly aligned with the Sun's own equator, threading the orbits of the planets with uncanny grace. Its path required almost no correction, as though it had been planned to minimize encounters and resist gravitational tug. To some, it was coincidence. To others, choreography. A trajectory is a story written in motion. Every push, every drift, every faint gravitational whisper leaves its mark. So when motion appears too smooth, we look for missing forces. Perhaps hidden jets of gas balanced one another perfectly. Perhaps magnetic fields nudged it into harmony. Or perhaps, as a few dared to ask, we were witnessing the relic of an older intelligence, a vessel still moving on orders given long ago. The thought was intoxicating, yet unsettling. If such precision were intentional, then its stillness was a form of speech, the way a compass points without moving. But scientists know better than to leap to conclusions. They speak instead in probabilities, in confidence intervals, in careful maybes. Astrophysicists still debate whether the apparent perfection was real or an illusion born of incomplete data. Every observation has limits. Every orbit hides uncertainty. Yet even within those margins, the elegance of the curve remained hard to dismiss. Cold outgassing, precise trajectory, two phenomena that seem opposed, one disorderly and thermal, the other mathematical and cool, and yet, somehow, 3i Atlas managed both. It exhaled softly without heat while gliding through gravitational shoals as if immune to chaos. To many it felt almost alive. There's a quiet beauty in the idea of cold fire. On Earth, we think of flame as hunger, the rapid oxidation that devours fuel and leaves ash. But in the cosmos, flame can mean something different. The glow of particles meeting, exchanging energy, and parting again without destruction. The auroras above polar worlds burn coldly. Their light a product of electrons dancing through magnetic lines, never touching what they illuminate. Maybe 3i Atlas carried that same kind of flame, a low whisper of energy that reshaped the space around it without consuming itself. We've seen glimpses of such behavior before. The moons of Jupiter vent gas and frost from fissures, yet remain frigid. Saturn's moon Enceladus releases towering plumes from its icy crust, their source still not fully understood. The cryovolcanoes of Neptune's moon Triton eject nitrogen gas hundreds of kilometers high, driven by sunlight barely strong enough to melt a shadow. Cold fire, it seems, is not contradiction but possibility, a kind of energy that moves gently instead of violently. So perhaps 3i Atlas isn't disobeying physics at all. Perhaps it is teaching us that our definition of combustion is too narrow, our sense of motion too human. Maybe it drifts with balance because balance is its nature. Maybe its faint emissions are the quiet hum of equilibrium, the way stars sing in gravity waves too slow for us to hear. For the scientists who study such things, the temptation is to model it, to feed its behavior into equations of thermodynamics, to quantify serenity. But there's something poetic that resists capture. The idea that an object could travel billions of years through vacuum, maintaining both composure and precision, feels almost moral. It mirrors what we admire in our own heroes: calmness under pressure, purpose without haste. Somewhere in those discussions, someone called 3i Atlas the monk of comets. It glows but does not burn, moves but does not falter, exists but does not explain. That phrase caught on quietly in forums and interviews, a small human metaphor trying to grasp something inhumanly patient. And perhaps patience is exactly what it demands from us. The data are incomplete, the observations few. All we can do is wait as the object continues its slow passage toward the sun, tracing an orbit we barely understand. Maybe in that waiting, we mirror it. Our curiosity, like its cold fire, releases energy without consuming fuel. We think, we wonder, we debate, and still we drift, unhurried toward understanding. The trajectory of knowledge, too, is long and delicate. It bends through gravity wells of doubt and illumination, each discovery a small course correction toward truth. If 3i Atlas truly carries within it both chill and precision, then it stands as a quiet lesson on how to move through the unknown. No rushing, no burning, only steady radiance, only gentle persistence. Perhaps that's the deeper message behind its cold fire, that the universe, vast and indifferent, still allows for grace in motion. By the time talk of cold fire had spread through the community, another phrase began to ripple outward from private channels into the open world, the cue ball hypothesis. It sounded like science fiction, yet it was rooted in genuine physics, a quiet corner of quantum theory where matter can exist not as particles or dust, but as coherent waves of energy wrapped around themselves. Some physicists call such entities non-topological solitons. Others, more poetically, call them pockets of persistence. According to the leak, one ESA theoretician had suggested that 3 Atlas might not be a comet at all, nor even solid matter in the usual sense, but a cue ball, a quantum object stable enough to survive interstellar travel, storing energy the way a magnetic field stores potential. In that view, the strange chemistry, the cold outgassing, the impeccable trajectory might all be side effects of a physics we barely glimpse. It's an idea older than it sounds. In the 1980s, theoretical physicists speculated that after the Big Bang, the universe might have produced such coherent lumps of scalar fields, condensations of energy that never decayed, travelling intact through cosmic history. Most would be microscopic, invisible even to our most sensitive detectors. But some calculations allowed for giants, mountain-sized or larger, stable enough to mimic asteroids yet lighter than they should be. They could pass through galaxies unscathed, deflecting magnetic fields, glowing faintly when disturbed by sunlight. The notion is breathtaking, but it lives at the edge of plausibility. No confirmed cue ball has ever been observed. Their existence remains a speculation born of equations, not experiments. Still, the idea tempts because it offers an explanation that feels both exotic and elegant, something beyond machinery, beyond biology, yet still alive in a mathematical sense. If 3i Atlas were such a construct, it would be neither natural nor artificial as we understand those terms. It would simply be a survivor from a younger universe, carrying within it the frozen rhythm of creation itself. Its outgassing could be quantum leakage, slow decay of an internal field. Its stability could be inherent, a property of the vacuum it embodies, and its chemistry, if any, would be the residue of ordinary matter trapped in its gravity like dust around a magnet. To imagine such an object is to blur every boundary we draw between life and physics, because life, at its most basic, is the tendency of matter to preserve form against entropy. A cue ball does that perfectly. It keeps its coherence while the universe around it expands and cools. In a sense, it remembers what the early cosmos felt like. It is a fossil made of mathematics. Some researchers entertain the hypothesis privately, not as belief, but as thought experiment. What if the universe is littered with such things? Remnants of primordial fields, drifters that seed gravitational perturbations, inspire myths, or masquerade as comets? We may already have passed thousands without knowing. Our instruments are tuned to matter, not to the whisper of a scalar field. We see what interacts with light. Cue balls, if real, might barely do so at all. It's humbling to realize how narrow our senses remain. Every telescope is a filter. It shows us only one slice of reality. Infrared reveals warmth, ultraviolet shows ionization, radio maps electrons. But the deeper structures of the universe, the quantum scaffolds that underlie it, are mostly silent to these eyes. If 3i Atlas belonged to that hidden layer, then our confusion would be natural. We'd be watching a language we were never taught. There's another possibility, though, one that bends philosophy more than physics. Some thinkers have speculated that intelligence itself could one day transcend biology, migrating into forms of energy or field. If consciousness is a pattern of information, and if matter can hold pattern, then perhaps evolution doesn't stop at carbon. Perhaps it continues into quantum coherence, into entities that move through galaxies as pure organisation, no machinery, no cells, only sustained awareness woven into the vacuum. To us they would appear as silent wanderers, glowing faintly, obeying trajectories of perfect calm. It's a romantic idea, but not entirely detached from science. Our computers already manipulate qubits, small regions of matter balanced between states. They exist in superposition, much like those hypothetical solistons. Scale that up 1 billion-fold, add eons of self-refinement, and who's to say consciousness could not inhabit such stability? If so, 3i Atlas might not simply be a relic, it might be a messenger from a different era of existence. Of course, most astrophysicists smile gently at such leaps. They know the difference between speculation and evidence. A missing spectral line is not proof of post-biological life. An elegant orbit is not a sign of guidance. But they also know that today's impossibilities sometimes become tomorrow's textbooks. The boundary between science and imagination is permeable, and that permeability drives progress. Even if the cue ball idea proves wrong, it has already served a purpose. It reminds us that the universe can host forms beyond our vocabulary. It nudges open the door of imagination just wide enough for humility to step through. Late at night, when the data flickers on a monitor and the air in the observatory hums with electricity, it's easy to forget that we too are arrangements of fields, temporary coherences in a wider wave. Maybe that's why the notion of a quantum traveller feels strangely intimate. It speaks to something within us that also seeks to persist, to remain coherent through the noise of time. Perhaps the truth about 3i Atlas is entirely ordinary, a shard of rock, a dusty comet, a coincidence in motion. But perhaps its mystery lies not in what it is, but in what it makes us remember, that the universe still contains things so patient, so inscrutable, that even our brightest instruments can do nothing but watch and wonder. And maybe that's enough. To watch and to wonder. That is how every new kind of knowledge begins. The rumour of a quantum traveller was still echoing when a new light appeared, one that wasn't a metaphor at all. On the dusty plains of Mars, the Perseverance rover tilted its navigation camera toward the sky and caught a thin white streak sliding above the horizon. 4 times longer than it was wide, slightly blurred at the ends, almost luminous. It wasn't the kind of image designed to break history, but it did. Because according to the telemetry, 3i Atlas was crossing that very region of the Martian sky. At first, it seemed like a coincidence. Rovers take long exposures often, capturing the faint movement of Phobos or the drifting clouds of Martian dusk. But when independent analysts measured the streak, they found something chilling. At the distance where 3i Atlas should have been, that thin white line corresponded to an apparent length of 50,000 kilometres. That's nearly 4 times Earth's diameter, far too large for any known comet nucleus, and far too straight to be a tail. Something was off. The internet filled the void before any agency could comment. Within hours, theories bloomed like spores in the dark. Maybe the streak was the actual body of 3i Atlas, a colossal cylinder veiled until now. Maybe it was a motion blur. Maybe something else had crossed Mars's sky entirely. People compared the image to the classic photographs of 1i Oumuamua, which had also puzzled scientists with its elongated form. But unlike Oumuamua, this streak seemed to dwarf comprehension itself. When Harvard astrophysicist Avi Loeb addressed the question, his tone was calm, even sympathetic. He explained that the image could indeed represent motion rather than structure. The Perseverance camera had likely stacked exposures over several minutes, tracking the stars instead of the moving object. At 3 Atlas's estimated speed, around 67 kilometers per second relative to the Sun, the object would trace a line tens of thousands of kilometers long during that time. If those exposures were combined, the result would be a white streak that mimicked size where there was only movement. Simple, elegant, reasonable. For most, that explanation was enough. But one sentence in Loeb's statement kept echoing in the margins. "If the image represents a single exposure shorter than 3 seconds," he wrote, "the brightness and angular length would imply a much closer, smaller, faster object not consistent with 3-eye atlas. In other words, if the rover hadn't been stacking images, then something else, something nearer to Mars, had made that light." NASA, citing the ongoing government shutdown, didn't clarify the exposure time or metadata. The file remained incomplete. It's remarkable how one missing line in a spreadsheet can fracture certainty. Without knowing how long the shutter was open, no one could be sure whether the image showed a distant traveller or a local visitor. And in that absence of detail, the imagination thrives. Some said it was a fragment shed by through-eye atlas as it passed Mars, a shard of something glinting. Others whispered of probes, small self-guiding artifacts detached before perihelion, sampling planetary atmospheres as they drifted inward. There was no evidence for any of it, only the silence of official comment and the slow heartbeat of speculation. But perhaps the fascination wasn't really about the object at all. It was about scale and how fragile our sense of proportion becomes under alien light. A streak across a camera sensor can stretch imagination as easily as it stretches pixels. We crave definition, a beginning and an end, but the cosmos rarely provides it. It paints in gradients, not edges. To stand on Mars, even through the eyes of a machine, and see something unexplainable pass overhead is to feel the ancient wonder of early astronomers. They too watched lines of light cross the sky and built stories to fill the gap between observation and understanding. Today our stories are dressed in mathematics, but they serve the same purpose, to bridge all with meaning. The streak above Jezero crater became a Rorschach test for humanity's curiosity. For some, it was proof of technology. For others, a reminder of the limits of our instruments. And for a few, it was simply beautiful, a testament to motion, time, and how light remembers every journey it makes. There's a quiet lesson in motion blur. When we photograph the stars and see trails instead of points, it's not the stars that move, it's us. Our planet spins, our cameras tremble, our time extends longer than our stillness. The universe is perfectly steady. It's our gaze that wavers. Perhaps the same is true for 3-eye atlas. Maybe it's not the object that confuses us, but the way we insist on freezing it in a single frame. The Martian night where that image was taken must have been silent beyond imagining. No wind strong enough to stir dust, no sound but the vibration of Perseverance's machinery. The mechanical heart of human curiosity beating quietly against an alien sky. Somewhere above, an object from another star crossed that silence, leaving nothing but a soft mark of light. Even if it was only an artifact of exposure, it was an artifact of wonder too, a collision between human design and cosmic motion. In the months that followed, researchers reprocessed the image dozens of times. Each iteration produced the same faint stripe, neither proof nor refutation. Like so many astronomical mysteries, it became less about answers and more about patience. A long exposure in its own right stretched across collective imagination. Maybe that's why the story resonates. Because a streak of light is what we are too, bright for an instant, then gone, our lives elongated by motion through time. 3 Atlas reminded us that every photograph of the universe is also a photograph of ourselves, our hope to hold still something that will never stop moving. When the streak above Mars became a mirror for our uncertainty, the world turned once again to Avi Loeb, the physicist whose name had quietly threaded through the entire mystery. For months he had been the steady voice between panic and possibility, reminding listeners that extraordinary claims require extraordinary patience. He began to speak less about images and more about equations, because sometimes the most revealing picture is drawn not by cameras, but by mathematics. Loeb's latest analysis appeared first in his online journal, Interstellar Diaries. a space for open thinking among data, dreams, and discipline. He described a chain of reasoning as delicate as orbit itself. From Perseverance's coordinates, camera field of view, and the relative velocity of 3i Atlas, one could predict precisely how long the object's trail should appear under different exposure times. If the line matched a 10-minute composite, the light was a moving point. If it matched a 3-second frame, the light was a local event, something smaller, faster, nearer. But no one could know until the metadata came back online. Mathematics can be a kind of lullaby. It lulls the restless mind with patterns, velocity multiplied by time, distance divided by angular size. Here, every number offered calm amid chaos, promising that reality still obeyed rules. And yet, each rule depended on a single unknown: how long the rover's electronic eye had stayed open. Without that, the universe could still slip through the cracks. Loeb wrote that science lives inside such cracks. He reminded readers that uncertainty is not failure. It is where discovery hides. The best we can do, he said, is to map the space between what we know and what we imagine. For 3i Atlas, that map was narrowing, pixel by pixel, theory by theory. But it was far from finished. He also emphasized something deeper, an idea that had guided his career since the days of Oumuamua. When data refuses to settle, you must resist the urge to simplify. A blurry photograph, a faint signal, a missing coordinate. These are not annoyances to be discarded, they are invitations. Each anomaly, properly examined, expands the border of understanding. The worst mistake is to force reality back into comfort before it's ready. Outside academic circles, Loeb's calm became almost mythic. Social media quoted him like a cosmic oracle. Nature is under no obligation to make sense to us, he said, echoing Feynman's old wisdom, but we are under every obligation to listen. His voice, steady, unhurried, stood in contrast to the fever of speculation around him. He never promised revelation, only the dignity of asking correctly. Behind the poetry of his prose lay precise physics. He outlined the relationship between brightness and distance, between exposure and saturation, and how scattered light can stretch like silk across a detector. The line from Mars might be no more mysterious than a moonbeam caught mid-motion, and yet he allowed a whisper of wonder. If the data later proved it was a single short exposure, then something extraordinary had passed above Jezero crater, something perhaps 50 times nearer than expected, a question flying through the thin Martian air. Loeb's reasoning became a parable about the scientific method itself. Every calculation is a window, but the frame is human, imperfect, trembling, sometimes blind. Still, we keep building windows because looking is the only honest act left to us. He compared the process to navigating by starlight through a fog. You never see the whole horizon, only the next glimmer, the next coordinate. Progress is not a leap, but a drift. There's humility in that image, the scientist as sailor, steering by uncertainty. And perhaps that is why Loeb's analysis resonated beyond academia. People recognize the quiet courage in admitting how little we know. In a world that rushes to declare truth, there is something almost revolutionary about a voice that says perhaps. Astrophysicists still debate his conclusions. Some call them elegant, others premature. But all agree that his discipline, to calculate before believing, is the heartbeat of science. He turned the 50,000-kilometre streak from a headline into a homework problem, and in doing so restored the calm rhythm of inquiry. Even doubt can be beautiful when expressed with care. It's easy to forget beneath the equations that every number represents light that has travelled millions of kilometres to reach us. Every photon in that Martian image was born in the sun, bounced from dust or ice, and carried through vacuum to a camera lens, then through deep space transmission back to Earth. Each one endured cosmic rays, magnetic storms, the frictionless silence of interplanetary night. To study such light is to study persistence itself. When Loeb wrote about that journey, his tone softened. He compared each photon to a messenger that has crossed the ages to tell us what is real. Some messages are distorted, others incomplete, but all deserve to be read with patience. Perhaps he suggested that's the real purpose of astronomy, to learn how to listen across distance and time without assuming the ending. Whether the streak was motion or magnitude, artifact or anomaly, Loeb's equation did something quiet and profound. It transformed speculation into serenity. It reminded us that the search for truth isn't a chase, it's a conversation conducted at the speed of light across a gulf of unknowing. And when that conversation pauses, when data falls silent or the signal fades, we wait. Because waiting is also part of the dialogue. The cosmos speaks slowly, and if we listen long enough, it always finishes its thought. There is a moment late at night when all the calculations and noise fall away, when what remains is a simple question that feels almost personal. What if the sky once said hello, and we missed it? The thought lingers whenever someone mentions the year 1977 and the word wow written in red ink on a computer printout. A narrow-band burst of radio energy lasting 72 seconds, captured by the Big Ear telescope in Ohio, so perfect in shape and frequency that astronomer Jerry Amon could only circle it and write that single exclamation beside the data. For nearly half a century, no one has heard anything like it again. No repetition, no echo, just one flawless syllable of the universe. When Avi Loeb traced 3I Atlas backward through space and time, he found that 48 years ago, it would have been crossing the same region of sky where that mysterious transmission originated. Not exactly overlapping, but close, within about 9 degrees of right ascension, a gap small enough to stir the imagination. The probability of such alignment by chance, he calculated, hovered near 1%. Not proof, but not nothing either. If that connection were true, it would mean that the most famous, unexplained signal in the history of radio astronomy wasn't random static at all, it was an announcement. A whisper sent from the edge of our solar neighbourhood, one that we only half caught before the source slipped into the void. A voice that then, decades later, may have returned. The wow! Signal's frequency, 1220 p. 456 MHz, wasn't arbitrary. It lies just beside the natural emission line of hydrogen, the most common element in the universe. That frequency has long been considered a likely channel for intelligent communication, a cosmic calling card understood by any species that studies atoms. To send a message there is to choose the language of creation itself. If the alignment between 3I Atlas and that ancient coordinate means anything, it raises a quiet question. What kind of transmitter could shout across 600 astronomical units and still be heard on Earth? Loeb ran the numbers. The power required would be on the scale of a nuclear reactor, a beam of 1 or 2 gigawatts focused across interstellar distance. Not absurd, not beyond technology, simply precise. The idea that the wow signal might have been engineered has always hovered on the border between science and myth. Skeptics point out that single events are unreliable. Terrestrial interference, satellites, natural mazes, any could produce such a spike. But the beauty of science lies in its tolerance for maybes. Until ruled out, the possibility remains open, like a faint tone still echoing under static. It's worth remembering what kind of world received that tone in 1977. Voyager 1 had just launched, carrying its golden record. Humanity was beginning to speak outward, tentative and hopeful. Then, days later, something perhaps spoke back. For decades we've wondered whether that was coincidence or dialogue. And now, as 3I Atlas sails through our system, that question hums again, low, insistent, familiar. The connection is speculative, yet strangely comforting, because even if the two events are unrelated, the symmetry between them reminds us how vast stories can circle back on themselves. A comet from another star passes our worlds just as one once may have whispered across radio waves. Two strangers at the edge of hearing, orbiting each other in possibility. Astronomers still debate the odds. A 1% correlation sounds small, but in a universe of hundreds of billions of stars, it's a heartbeat. And the human mind cannot resist connecting heartbeats into rhythm. We find patterns because we are made of them, our atoms arranged by the same forces that guide orbits and frequencies. Somewhere within that connection lies an even softer truth, that we yearn not only to know, but to be known. Every telescope we build, every signal we monitor, every probe we send outward is an act of loneliness transformed into curiosity. The wow signal endures not because it proves anything, but because it reminds us that we are listening. If 3i Atlas carries any echo of that event, we may never know. Radio telescopes today could test the idea easily, yet none have publicly done so. Perhaps funding, perhaps caution, perhaps fear of embarrassment, each reason quietly human. Still, the silence around that frequency feels heavier now, weighted by potential meaning. As though the cosmos cleared its throat once, long ago, and we haven't yet dared to ask it to speak again. There's something beautiful in that restraint. Science often grows not through answers, but through questions left open like windows. Each mystery invites us to keep our instruments tuned, our hearts steady, our imaginations gentle. We may never receive another burst like the one from 1977, or we may, tomorrow without warning. The only certainty is that someone will still be listening beneath whatever sky we inhabit. The faint possibility that 3i Atlas and the wow signal share an origin turns the cold mechanics of astronomy into something intimate, a correspondence between epochs, a message sent when humanity had just begun to whisper back to the universe, and arriving now when we're ready, perhaps, to understand how fragile communication can be. Maybe that's all the wow meant. Not proof of company, not confirmation of purpose, just a single cosmic syllable of existence, and after decades of static, maybe 3i Atlas is the pause before the next word. The story of the wow. Signal had been rekindled, and with it, a new wave of anticipation swept across observatories and online communities alike. Everyone wondered the same thing. If 3i Atlas passed near the origin of that signal, why wasn't anyone listening now? In theory, a few well-timed observations could settle it. Just point a radio telescope toward the object and see if it whispers again. But the skies remained strangely quiet. Not from the stars, but from us. Weeks passed. No official announcements, no coordinated SETI campaigns, no new data. For the first time in years, the silence seemed deliberate. The same nations that had raced to observe the flyby now appeared frozen, watching each other instead of the sky. Conspiracies, of course, multiplied. People imagined secret channels alive with encrypted chatter, space agencies exchanging classified detections. But the truth may have been simpler and sadder. Bureaucracies don't dream. When money or politics collides with wonder, wonder waits. It is strange to think that, in an age where our telescopes can detect planets orbiting other suns, not a single dish was publicly aimed at an interstellar visitor crossing our doorstep. Even the amateurs, once the lifeblood of discovery, were quieted by uncertainty. Some said their posts were being flagged or hidden by algorithms. Others said their streams were demonetized the moment 3i Atlas appeared in a title. It was as if the internet itself had decided that speculation was no longer good for business. There is a term astronomers use, radio silence. In cosmic terms, it usually describes the quiet between signals, but lately, the phrase seemed to describe humanity better than space. We were the ones who had gone silent, afraid of our own curiosity. Perhaps that's the final irony. When we finally meet something that makes us feel small again, our first instinct is to look away. Yet beneath the hush, something subtler was happening. A few independent researchers, grad students, retired engineers, backyard experimenters, began to coordinate informally. They shared open-source scripts for pointing radio antennas, borrowed time on community observatories, and patched together listening stations from parts scavenged online. No funding, no permission, just faith that listening mattered. They tuned in around the same frequency the wow signal once sang, sweeping the sky along 3i Atlas's path. For weeks they heard nothing but the usual hiss of the universe. Cosmic microwave background, satellite interference, distant quasars humming like old fluorescent lamps. But even the noise held beauty, because noise means the cosmos is alive, vibrating, talking in a language of randomness. One night, a listener from Chile wrote, "Maybe silence is the message." Her words spread quietly through the small network of volunteers, and no one disagreed. Meanwhile, 3i Atlas continued its slow approach to the sun. Each day it drifted deeper into the solar plane, its brightness fluctuating in ways that defied prediction. Some models said it should dim as gases vented away, others predicted a brilliant flare. Instead it pulsed, softly, rhythmically, like a heartbeat behind clouds. The cadence was irregular but mesmerizing. A few days bright, a few days faint. Not binary, not mechanical. Just alive enough to tease. Somewhere within those fluctuations, the public found new meaning. Artists began painting the object as a cosmic pilgrim, half comet, half consciousness. Musicians turned light curves into melodies, transposing brightness into notes. The internet, for all its noise and suspicion, found its poetry again. Maybe that was 3i Atlas's quiet gift, not to answer questions, but to remind us how to wonder together. And still, the institution stayed mute. No radio signals announced, no spectra released. Officially, agencies cited review protocols and data integrity checks. Unofficially, insiders whispered that the silence wasn't total, only public. That deep within encrypted channels, certain observatories had indeed detected faint periodic emissions near the hydrogen line. Too weak to call a signal, too regular to call noise, but confirmation requires consensus, and consensus fears ridicule. So the data waited, quietly, as the object slipped behind the sun. It is easy to imagine this kind of restraint as conspiracy, but maybe it is something gentler, fear of magic. Scientists, like poets, can be superstitious about meaning. To acknowledge the extraordinary too soon is to risk faith in method itself. Better to pause, to verify, to let the unknown cool before touching it again. Perhaps that's why they called the project Heliopause Review, a promise that after 3i Atlas emerged from behind the sun, observation would resume. Until then, the world could only wait. There's a certain beauty in collective waiting. Across continents, people began watching the sunrise, knowing that somewhere beyond that light, a question was hidden. In the calm before dawn, the air feels different, thin, metallic, like the space between frequencies. Maybe that's what listening truly means, holding still long enough to let possibility find you. The silence surrounding 3i Atlas wasn't emptiness. It was potential. It was the universe holding its breath. And in that held breath, humanity remembered its oldest habit, to pause before the divine. As 3i Atlas drifted closer to the sun, its motion seemed almost ceremonial. It entered the plane of the solar system with uncanny precision, an inclination of less than 5 degrees, as if it sought to join our family of worlds rather than simply pass through. That alone was enough to unsettle even the calmest orbital dynamicists. Interstellar visitors are supposed to arrive from all directions, thrown by the random tides of galactic motion. Their inclinations should vary wildly, a chaotic scatter across the ecliptic. Yet 3 Atlas approached as though it had read our maps first. At such a shallow angle, its path wove gracefully between planetary orbits, like a dancer threading through moving circles. Mars behind it, Earth ahead, Venus waiting closer to the sun. From a certain perspective, the alignment looked almost intentional. A grand, silent procession along our system's equatorial stage, and as its orbit flattened, its brightness steadied. The faint pulsing that had marked its earlier weeks smoothed into a constant pale radiance. Observers compared it to a pearl moving through twilight. In astronomy, inclination tells a story of origin. Comets bound to our sun tilt in all directions, their angles testifying to ancient collisions and gravitational chaos. But to arrive at under 5 degrees of inclination from interstellar space is statistically improbable. Like tossing a coin from another continent and having it land perfectly balanced on an edge. Such precision isn't proof of purpose, but it whispers of pattern. And pattern is the seed of suspicion. Some researchers proposed that the object's low angle was the result of long-term galactic drift. Perhaps over millions of years, gravitational interactions with molecular clouds had gently nudged it into the galactic plane, making its encounter with our solar system appear deliberate. Others suggested it was simply luck, that among countless random trajectories one was bound to align. Probability allows miracles, time provides the stage, but still, the numbers felt too neat. There's a quiet rule among orbital scientists. When something looks too perfect, check your assumptions. It's easy to forget that we too move within the same geometry we measure. Our sense of randomness is shaped by our vantage point. If the cosmos is a vast pattern, then our surprise at its coincidences may be more a reflection of our ignorance than of its intention. Perhaps every star system seems aligned when viewed from somewhere else. Even so, the inclination stirred deeper philosophical murmurs, because if 3i Atlas truly entered along our ecliptic, it would pass close to the gravitational balance points between the planets, those invisible harbours known as Lagrange regions, where the pull of two bodies cancels perfectly. Such paths are the highways of celestial navigation. We use them to park spacecraft, to save fuel, to drift quietly between worlds. To see an interstellar object glide through them was like watching a stranger walk confidently through secret doors. Was it coincidence or choreography? No one could say. The equations allowed both, but the symmetry of its route drew attention from unlikely places, engineers, mathematicians, even artists. They began sketching models of gravitational artistry, tracing how a body might move through multiple wells of potential energy without collision, like a pearl rolling across a bowl without ever falling in. The solar system, seen this way, became less a collection of planets and more a symphony of gentle pulls, each note influencing the others, and 3 Atlas seemed to play the melody perfectly. Such elegance raises uncomfortable questions, because in nature chaos is easy, precision is expensive. To achieve an orbit nearly parallel to ours, an object from interstellar space would need either immense time or careful tuning. If it were natural, we would expect more like it. Other interstellar wanderers crossing the ecliptic as gracefully. Yet the few we've found, Oumuamua, Borisov, came in at steep, defiant angles. Only this one arrived as if it sought the sunlight head-on. That precision also carried practical consequences. The shallow approach meant that sunlight would strike its surface evenly as it neared perihelion, minimizing the violent outgassing that destroys most comets. In theory, it could survive intact, perhaps even alter course subtly as radiation pressure built. Such behavior would be easy to interpret as control. Loeb himself, cautious as ever, called it a trajectory optimized for survival, and survival in cosmic terms implies intention, or luck so profound it might as well be intention. As the world watched, anticipation swelled toward the object's solar passage. For weeks, no ground-based telescope could see it anymore. Even space observatories struggled, blinded by the sun's glare. 3 Atlas had entered the one region of sky no one could follow, the glare of the source itself. To astronomers, this phase is called solar conjunction. To poets, its disappearance. And to dreamers, its metamorphosis. If its course truly was aligned with the solar plane, Then at perihelion it would slip directly behind the sun from Earth's point of view, hidden within the furnace of daylight. It would be unreachable for nearly a month, no data, no images, just waiting. Some compared it to a cocoon stage, the object passing through the heart of light before emerging again. Others feared that if it were truly artificial, this was the moment something might change, an activation, a release, or a quiet self-destruction. Whatever secrets it held would remain veiled by our own star. It's almost poetic, isn't it? That an object suspected of impossible origins would vanish at the moment of closest revelation, swallowed by the brightness that makes life possible. Perhaps the universe understands drama better than we think. Astronomers scheduled everything for the re-emergence. Radio arrays, space telescopes, even the newly awakened JUICE mission near Jupiter. But until that day came, humanity could only imagine the silence beyond the sun, where a wanderer from another star sailed through pure light, its path so perfectly matched to ours that, for a while, it shared our plane of being. And somewhere beneath that same sun, millions of us stood in daylight, unaware that just beyond vision, a traveller moved in harmony with the system that raised us. It was there, unseen, balanced within the music of gravity. A stranger that, for a fleeting moment, danced as one of us. As the weeks passed and 3i Atlas slipped into the glare of the sun, the world entered a strange kind of twilight. Not a darkness of light, but of knowledge. Every telescope that had followed the object went blind to it at once, their sensors saturated by solar brilliance. Even the most advanced coronagraphs designed to block the sun's disk and see what hides beside it could not yet pierce the radiance. For the first time since its discovery, 3i Atlas was beyond reach, and that made the waiting harder than ever. We have always been uncomfortable with absence. In a universe built on light, the moment something disappears feels almost personal. Scientists tried to distract themselves with predictions. They calculated perihelion distance, just inside Mercury's orbit, and modelled how heat and solar wind might change the object's surface. Would it brighten? Would it fragment as comets often do? Would it vanish entirely, leaving only a trail of ions twisting through the sun's magnetic field? But something about 3i Atlas defied those expectations. Its faint tail, measured before conjunction, had grown shorter, not longer. Instead of vaporizing under sunlight, it seemed to be shedding less. A comet that cools as it approaches heat. A paradox wrapped in silence. In ancient times, when stars dimmed or vanished, people imagined them passing through hidden gates of heaven. Today we call it conjunction, but the feeling is the same, a sense of suspension between what was and what might return. Perhaps that is why even hardened physicists admitted to a strange unease during those weeks. Every day the sun rose, brilliant and ordinary, yet beneath its brilliance something extraordinary was moving unseen. Rumours returned, as they always do in silence. A few online forums claim that shortwave radio operators had detected faint fluctuations in the solar spectrum, periodic blips repeating every 42 minutes. Others swore that satellites in low orbit were catching unexplained electromagnetic reflections from the inner system. No official agency confirmed anything. But confirmation was hardly the point. The act of wondering had become a ritual, shared quietly across time zones. People refreshing news feeds at dawn, hoping for the first glimpse of re-emergence. It's odd how absence unites us more than presence. When something vanishes into light, everyone becomes equal before it. There are no experts in waiting, no professionals in patience. Only the shared breath of curiosity. Even those who had mocked the hype found themselves glancing at sunrise with a twinge of curiosity, knowing that beyond that burning horizon, a question was still moving. Meanwhile, models kept shifting. Computer simulations run at the European Southern Observatory suggested that based on the object's last recorded velocity, its course might not remain purely gravitational. The slight deceleration noted just before conjunction couldn't be explained by solar radiation pressure alone. It was as though something resisted the sun's pull, subtly, gracefully, deliberately. The change was minuscule, but consistent. If correct, it meant the object might not follow its predicted outbound arc after perihelion. It might linger, even become bound, capture. That word carries weight in celestial mechanics. Our solar system captures very little. Its gravity well is deep, but its geometry is unforgiving. An interstellar object entering at tens of kilometers per second should escape easily once it swings past the sun. For 3I Atlas to remain would require an improbable exchange of energy, a nudge, a jet, or something entirely new. But when the simulations accounted for that possibility, a beautiful outcome appeared on screen. An elongated orbit threading between Mars and Jupiter, looping through the asteroid belt like a ribbon of foreign light. If that trajectory proved real, 3I Atlas wouldn't leave. It would stay, the first permanent visitor from another star. Somewhere deep inside ESA's data servers, engineers ran contingency programs. What instruments would need recalibration? Which satellites could track the object once it emerged? The JUICE mission, currently slingshotting near Jupiter, could perhaps capture long-range spectroscopy in November. Others proposed using the James Webb Space Telescope to catch thermal echoes once the sun's glare subsided. For now, though, all they could do was wait. The waiting became a kind of collective meditation, stretching across continents and disciplines. For those attuned to metaphor, the image was irresistible. A foreign traveller approaching the heart of light, unseen yet unwavering. A cosmic pilgrim entering the temple of the sun, its mysteries veiled until it emerged renewed. In mythology, such journeys always mark transformation. The hero descends into radiance, dies symbolically, and returns changed. Astronomy, it seems, has its own myths written in orbits instead of words. The object's predicted reappearance date was November 2nd. Observatories on Earth and in space were poised to capture it as soon as geometry allowed. Somewhere in that anticipation, the world began to quiet again, not out of suppression this time, but reverence. Everyone knew that what emerged could alter how we think about comets, or about the boundaries of nature itself. Or it might be nothing, just dust, symmetry, and coincidence. Either way, the outcome would change the story we tell ourselves about wonder. A few poets online called it the solar chrysalis. Others preferred the eclipse of certainty. But whatever name it carried, it had become more than an object. It was a symbol of what happens when humanity looks too deeply into the unknown and finds both fear and beauty staring back. Perhaps that's why the silence during its disappearance felt almost sacred. It was as though the universe had drawn a curtain, asking us to stop explaining for a moment and simply wait. And waiting, in its own quiet way, is faith. Faith that light will return. Faith that curiosity still matters. Faith that even if the answer is mundane, the act of asking was worth it. So the world turned beneath the sun, ordinary and unchanged, while just beyond its blaze, a traveller crossed the point of no return. No one could see it, but somewhere in that blinding distance, 3I Atlas was writing the next line of its story, in the oldest ink we know, light itself. The days around November 2nd arrived like held breath. All over the world, observatories came back online, their instruments cooled, recalibrated, and turned toward the sun's opposite sky. In Chile's Atacama Desert, the morning air shimmered as technicians unsealed domes before dawn. In the Canary Islands, engineers adjusted optics to pierce the low horizon. In Australia, students at the park's observatory brewed coffee and whispered in the dark, waiting for telemetry. It had been nearly a month since 3I Atlas vanished behind the sun, and now, as the Earth's orbit carried it back into alignment, the window reopened. The silence was about to end. The first detection came from a small French satellite designed to study solar radiation. At 0413 UTC, one of its onboard coronagraphs recorded a faint speck emerging from the sun's corona, a point of light slightly dimmer than expected but perfectly positioned along the predicted exit path. It wasn't dramatic, it was quiet, almost modest, a grain of brightness where there should have been none. Moments later, telescopes in India and South Africa confirmed it. 3I Atlas had survived perihelion. That single fact defied probability. Most comets approaching that close to the sun either fragment or vaporize. Temperatures soar above 1,000 degrees, volatile ices boil violently, and the gravitational shear often tears their nuclei apart. But 3I Atlas emerged intact, glowing steadily, its coma smooth and compact. No debris cloud, no turbulence, just quiet light, moving with the same calm geometry as before. Within hours, new data revealed something stranger still. Its outbound velocity was lower than expected by nearly 5%. A small number, yet cosmically significant. It meant that the object had lost kinetic energy, or perhaps redirected it. Gravitational interactions alone couldn't explain it. Solar radiation pressure would have accelerated it, not slowed it. Something else had occurred within that month of invisibility, something we could not see. Speculations flooded every corner of the scientific community. Perhaps 3I Atlas had vented material on the sun-facing side, releasing thrust opposite its motion. Perhaps the object's surface had reoriented, absorbing radiation differently. Or perhaps, whispered more than spoken, it had changed its course deliberately. Loeb, ever the careful skeptic, commented only that any anomalous deceleration near perihelion deserves rigorous study. But even his cautious phrasing carried weight. Across the following nights, the object brightened slightly, reflecting sunlight in pulses. Not rhythmic enough to suggest rotation, not chaotic enough to be random. Like a heartbeat, irregular yet deliberate. Amateur astronomers again joined the effort, their cameras stacking thousands of exposures to trace those subtle variations. The pattern when plotted resembled a curve rising and fading roughly every 6 hours, almost as though the object was slowly breathing. Astronomers hesitate to anthropomorphize, but language sometimes fails before wonder. One paper described the phenomenon as modulated reflectance consistent with oscillating albedo. Another, more candidly, called it the pulse. Whatever it was, it seemed to mark a new phase. By November 10th, the ESA's solar orbiter had managed to obtain high-resolution imagery at multiple wavelengths. Those images, later described but not yet released, reportedly showed faint bands around the nucleus, concentric halos of dust and plasma that appeared unusually symmetrical. An internal report leaked 2 days later used the phrase spherical stratification of unknown mechanism. The symmetry was too clean to be turbulence, too ordered for outgassing. Somewhere between physics and poetry, the object seemed to be sculpting itself. The data painted a picture more surreal than any earlier rumour. Imagine a comet that refuses chaos, that smooths its own eruptions into rings, that drifts away from the sun cooled rather than scarred. It was as though the laws of thermodynamics had been persuaded gently to make an exception. Public reaction was immediate and divided. Many called it confirmation of intelligence. Others saw only the beauty of nature's hidden symmetry. Astrophysicists reminded everyone that perfection doesn't always imply purpose. Crystals, too, form in silence and precision. Still, the coincidence of every anomaly, composition, motion, thermal behaviour, was beginning to feel like a choir singing one note, and no one could say whether that note was mechanical or divine. In the background, a quieter story unfolded. Financial markets, already uneasy from months of speculation, trembled slightly as 3I Atlas brightened. For reasons more psychological than practical, every new anomaly stirred the same reflex: uncertainty. When people realize that the universe can surprise them, confidence wavers. It's an ancient instinct, the same fear that once made sailors pray when comets appeared over open seas. Now, in digital age, the prayer took the form of numbers on a screen. Avi Loeb warned gently in an interview that panic is rarely productive, but markets, like stars, often ignore philosophers. As December approached, the outbound path of 3i Atlas became clear. Its new trajectory suggested a long looping orbit that might bring it back near the Sun in 70 years. Not an escape, but a capture, bound, at last, to the system it had crossed so effortlessly. If that orbit held, humanity would see it again, not in our lifetime, but in our grandchildren's. A foreign traveller turned quiet resident, circling within the same sunlight that once blinded us to its passage. The night the data confirmed its new orbit, observatories around the world released a joint statement, one of rare unity. It said simply, 3 Atlas remains under observation. Its behaviour is consistent with a bound object. Further study is required. There were no conclusions, no speculation, only the calm language of awe disguised as caution. Somewhere between those careful lines, the world felt a quiet thrill. The first interstellar object to enter our solar system had chosen, by accident or by physics or by something we do not yet understand, to stay. Whatever it was, whatever it meant, the sky had gained a new citizen. And perhaps, in that act of remaining, it had told us the only message we needed, that even across light years, even through silence and heat and doubt, not everything drifts away forever. Some things, some mysteries, choose to belong. When the official statement confirmed that 3i Atlas was now gravitationally bound to the solar system, a hush passed through the scientific world. It wasn't the silence of secrecy this time, nor the anxious void that had followed its first appearance. It was reverence. Like monks after a bell, everyone stopped speaking at once. Because somewhere between speculation and fact, the impossible had quietly become ordinary. An interstellar object had joined our sun's family. The word capture echoed through the days that followed. In celestial mechanics, capture is an accident of balance, the brief window when a traveller loses just enough energy to stay. It happens to dust and asteroids occasionally, to moons born from impact or gravitational theft. But never before had we seen it happen to something from beyond our star. 3 Atlas was now a citizen of the inner system, tracing a long ellipse between Mars and Jupiter, its aphelion at the rim of the asteroid belt, its perihelion just inside Venus, its orbital period 71 years, its inclination still less than 5 degrees, a newcomer that moved like it had been here forever. The first nights of observation after the capture felt different. Astronomers spoke softly in control rooms, as though raising their voices might disturb it. Telescopes across the world followed its arc. Cerro Paranal, Mauna Kea, La Palma, the new Louvois array in orbit. And as data came in, something subtle emerged. The object's reflected light carried a faint polarization shift, a sign that its surface might not be smooth rock or ice but structured. Microscopic layers aligned in consistent directions. To some, that meant crystalline frost, to others, fabrication. The debate flared again, but with less venom now, maybe because everyone sensed we were past the threshold of certainty. Whatever 3i Atlas was, it was staying. That fact alone began to reshape priorities. NASA convened a quiet committee to explore mission feasibility, an intercept in the 2030s using ion propulsion, perhaps launched from lunar orbit to match the object's plane. ESA proposed a joint concept called a Drastea, a small autonomous probe that could rendezvous and orbit it for months. China's National Space Administration announced plans to retask an upcoming asteroid explorer, to consider trajectory options for an extended interstellar target. For the first time in history, multiple nations plan to visit the same foreign visitor, not out of competition, but collective awe. But even as engineers dreamed of close-ups, theorists returned to the mystery of how it had been captured at all. Simulations showed that for an object moving at 67 kilometers per second, the odds of deceleration into a stable orbit without collision or fragmentation were nearly zero, unless, of course, the object had help from itself. That idea was too delicate to state outright, yet it hovered in papers under euphemisms: non-gravitational vector influence, active momentum adjustment, unknown radiative asymmetry. Each phrase meant the same thing: thrust. Not rockets, not fire, just a subtle push against gravity, perfectly timed, perfectly scaled. A whisper of control. And whether that control was mechanical or natural no longer mattered. Either way, 3i Atlas had written new physics into its path. The data also hinted at something even more curious: stability. Most captured comets drift chaotically, their orbits precessing under Jupiter's tug until they spiral inward or escape again. But early integrations suggested 3i Atlas's orbit would remain steady for centuries. Its period, its angle, its eccentricity, each locked in harmonic resonance with Earth's orbit, an almost musical ratio of 1 to 71. Such synchrony seemed to defy randomness. It was as though the cosmos had tuned a string and let it vibrate softly between planets. Artists began to illustrate it. A slender arc of light looping through our solar family, glowing faintly between Mars and Jupiter like a quiet signature. Children wrote essays calling it the guest star that stayed. Even skeptics couldn't resist the metaphor: the first immigrant from another sun. We had spent centuries sending probes outward, and now, at last, something had chosen to stay with us. Yet the more we measured it, the more elusive it became. Radar reflections from deep space networks came back weaker than expected. Its albedo fluctuated irregularly, sometimes too bright for its calculated size. Thermal emissions failed to match any known material curve. Some days it acted like a comet, others like a metallic body, as though it had more than one face or more than one story. Astrobiologists approached it from another angle. If interstellar chemistry had seeded life across worlds, perhaps 3i Atlas carried more than dust. Even fragments could hold isotopic secrets, molecules shaped under alien stars. To capture one was to capture a sample of the galaxy itself, a messenger frozen between origins. Some scientists said it might reveal not what life is, but what matter can become when given enough time. Meanwhile, ordinary people found themselves looking up again. In late December, when the skies cleared, you could just glimpse it through a modest telescope, magnitude 10, a faint smear near the constellation Pisces. Tiny, anonymous, yet famous beyond reason. Those who saw it described a feeling hard to name. Not excitement, not fear, but recognition. As if seeing a reflection of something that had always been there, waiting for us to notice. It's strange how discovery changes nothing and everything at once. The world continued spinning, cities awake, traffic humming, messages flickering across screens, and somewhere above it all, a small interstellar body traced its gentle ellipse, indifferent to our attention, wrapped in the slow music of the sun. For now, that was enough. No signals, no revelations, only motion, the purest form of truth the universe ever offers. Perhaps, in some deep way, that is the real lesson of capture, that not every encounter ends in departure, that even across the gulfs between stars something can choose to linger quietly, teaching us that home is not a place, but an orbit we learn to share. By January, the data streams converged. 3 Atlas had settled into its new orbit, predictable, graceful, and utterly inexplicable. For months it had been the guest we couldn't stop talking about. Now it was family, quietly circling the sun like a distant cousin who never left the dinner table. Astronomers began to call it simply the object, a title both respectful and practical, because names, like theories, can constrain the imagination, and this one refused every boundary we tried to give it. Its light curve stabilized, smooth, steady, repeating every 29 hours. Spectroscopy hinted at subtle, rhythmic fluctuations in reflectivity, a pattern, not random. ESA's Solar Orbiter and NASA's Parker probe both recorded intermittent electromagnetic ripples near its orbital crossing, faint but measurable, a few kilohertz wide. To most physicists, these were natural resonances, perhaps the interaction between solar wind and a conductive surface. To others, they sounded suspiciously like a signal. No one could decide which was more unsettling, the idea that the universe had spoken, or that it hadn't. Whatever those pulses were, they never repeated precisely. They were almost structured. Too irregular for language, too patterned for noise. Loeb cautioned restraint. Correlation, he said, is a seductive form of poetry. Still, he couldn't deny the coincidence. The intervals between pulses roughly mirrored the spacing of the old WOW, signal spectral peaks. That echo might mean nothing, or everything. The JUICE mission, now swinging past Jupiter, caught its first long-range view in mid-January. A soft glow against the star field, barely brighter than the background. Its onboard spectrometer detected a faint excess of emission near 2.3 microns, a wavelength associated with methane ice under extremely low temperatures. But the emission line was cold, too cold for methane sublimation. The only plausible explanation was radiative fluorescence, light absorbed and re-emitted by molecules held in some kind of lattice or shell. It was chemistry behaving like machinery. One of the mission's engineers described it perfectly in an email later leaked to journalists. It's as if the object stores sunlight and releases it back in measured breaths. That phrase, measured breaths, caught on. Soon, headlines around the world repeated it, each outlet struggling to translate the feeling behind the numbers, because the data, stripped of equations, described something deeply familiar: rhythm. And rhythm, in all its forms, is the signature of life, or at least of intention. But science moves slower than metaphor. In the following weeks, researchers around the world began testing every possible natural mechanism: electrostatic resonance, charged dust dynamics, slow spin modulation, internal crystalline oscillations. Each theory explained part of the data. None explained all. The simplest conclusion, that we didn't yet understand what kind of object this was, remained the truest. Still, the speculation spilled beyond science. News anchors spoke in hushed tones. Documentaries aired. Think tanks issued statements about preparedness for non-anthropogenic intelligence, a bureaucratic way to say we don't know what this means. Governments stayed careful. The United Nations issued a statement reminding the public that no evidence suggests artificiality. The US, EMEA and European space agencies announced a joint study committee, part scientific, part psychological, to evaluate global reactions to sustained anomalous celestial phenomena. And through it all, 3i Atlas drifted along its orbit, indifferent to every sentence written in its name. Astronomers, meanwhile, noticed a quieter change. The object's orbit had synchronized with a faint resonance in Jupiter's gravity field, a 3:2 ratio that meant it would never approach too close nor stray too far. It was locked, delicately balanced between two giants, held in place by opposing pulls. Such resonance ensures long-term stability. It's how Pluto survives without colliding with Neptune. But in this case, the lock seemed to have chosen itself. No random object should have settled there by chance. It was as though the universe had found a new chord to play. And maybe, in a way, it had. In every field of study, coincidences like these become invitations. Theoretical physicists began re-examining gravitational models that allowed self-regulating trajectories, objects that could exchange momentum with solar wind or magnetic flux. Quantum chemists proposed new forms of superconducting ice, explaining the cold luminescence without invoking design. Philosophers joined in too, suggesting that we may be witnessing a natural phenomenon so ordered that it merely appears intentional, like a spiral galaxy mistaken for a fingerprint. There's something humbling in that possibility, that perhaps the universe in its complexity can imitate the deliberate, that what looks like a message may only be the grammar of physics spoken fluently for once. Even so, the feeling remained. 3i Atlas had not just joined our system, it had anchored itself to our imagination. By late February, the object became visible again through amateur telescopes as a faint point of silver against the backdrop of Aries. Small observatories organised public viewings, crowds gathering in quiet awe. People stood in fields and deserts, bundled against cold night air, looking at a tiny light that had crossed from another star and chosen to stay. No one could hear it, but many swore they felt something, a kind of low awareness, the way you feel a distant storm through air pressure rather than sound. Maybe that's what wonder really is. The body remembering that it too is made of atoms that once drifted between stars. That we are not separate from interstellar travellers, but their descendants, risen briefly to consciousness and looking homeward. Some nights, under clear skies, you can almost sense the symmetry. A silent object circling the sun with us, a mirror to our curiosity, both of us captives of the same light. It is bound now, as we are bound, by gravity, by uncertainty, by longing to know what we truly are. Perhaps 3i Atlas came to remind us that the difference between discovery and reflection is thin as starlight. That sometimes, when the universe sends something across the void, it's not to announce its presence, but to hold up a mirror and let us see our own. By March, 3i Atlas had become a fixture of both science and culture. It moved quietly between Mars and Jupiter, never straying far from the ecliptic, a new faint light among countless old ones. The data kept flowing, steady, mysterious, polite. No flares, no catastrophes, no sudden revelations. Just a rhythm, soft as breathing, that refused to end. In universities, classrooms filled with students who had grown up under this story. They spoke about it not as a mystery to solve, but as a companion to study. Physics departments proposed whole courses under titles like Interstellar Visitors and the Architecture of Wonder. Philosophy classes used it to debate consciousness, perception, and humility. Even theology joined in, not with fear, but gratitude. The universe, they said, had written a psalm in orbital form. By now, humanity had adjusted to its presence. The panic, the speculation, even the disbelief had faded into a kind of cosmic acceptance. It was no longer about what it was, but what it meant to us. And in that shift, something profound happened. Science became tender again. Observatories around the world shared data freely for the first time in decades. Chinese, American, Indian, and European teams exchanged telemetry without the usual competition for credit. Even amateur astronomers were credited in publications, their backyard telescopes now honoured as part of a single global network. It was as though the object had gently synchronised us, the way Jupiter once synchronised its moons, each nation finding its resonance in a shared orbit of curiosity. Still, the details mattered. Every new data set deepened the puzzle rather than resolved it. The spectral lines of nickel still appeared without iron, stubbornly defying chemistry. The thermal reading stayed cool, never rising above 100 Kelvin, even when sunlight should have doubled that. Its reflectivity pulsed like a metronome, yet showed no rotational Doppler shifts to match. It was as if the object moved without spinning, exhaling light in controlled intervals rather than reflecting it passively. A comet that did not tumble, a rock that breathed, a mirror with a pulse, and through all this, 3i Atlas maintained its silence. If it ever emitted structured radio signals, they remained too faint or too subtle to decode. The large arrays kept listening. Greenbank, Fast, Meerkat, even the repurposed Alma dishes, tuned near the hydrogen line, waiting for something deliberate. But the cosmos kept whispering in its usual static, and perhaps that was the message. One evening, during a live panel discussion, Avi Loeb said something that captured the tone of the new era. He was asked whether he still believed Three-Eye Atlas could be artificial. He smiled slightly and replied, "Artificial or natural, what's the difference, once the laws that made it the same?" The audience was quiet, because that really was the heart of it. Whether built or born, whether conscious or coincidental, the object had shown that physics itself can be intelligent in its elegance, that sometimes the universe builds its own art. Meanwhile, the missions in development advanced. ESA's Adrastea probe design solidified, a small, autonomous craft with ion engines and high-gain optics, capable of rendezvous in 2034. NASA's proposed Nereus mission took shape around similar goals, emphasizing long-term orbit mapping and sampling of outcast material. For once, cooperation seemed natural. It wasn't a race, it was a pilgrimage. While agencies built machines, ordinary people built rituals. Musicians composed symphonies timed to 3 Atlas's brightness fluctuations, turning its light curve into melody. Artists painted it as a silver seed drifting through black water. Writers turned its orbit into metaphor, a reminder that even things that don't belong can find balance. Children pointed at sky maps and marked its tiny loop among the planets, as though tracing the path of a slow, eternal heartbeat. And slowly, humanity's gaze began to shift from suspicion to kinship, because the more we learned about the object, the more we realized how similar it was to us. Fragile, improbable, adrift between chaos and order, and somehow surviving. We too had crossed interstellar cold, carried by physics we barely understood, and found ourselves captured by a star. We too glowed faintly in darkness. Some thinkers called this realization the reflective principle, the idea that what we discover out there inevitably reveals what we already are. We looked for signs of intention in Three-Eye Atlas and found them only because intention already lived inside us. We read meaning into its orbit because meaning is what the human mind does to stay alive, and perhaps that is enough, to find beauty even if the cosmos never meant to give it. By late spring, the object faded from casual view again, dipping into the glare of the evening sun, but it didn't vanish from memory. In a sense, it had joined the quiet chorus of familiar things: Venus, Mars, the constellations. Its name no longer evoked panic, only peace. The world had absorbed it, the way oceans absorb the light of a setting star. It's tempting to say the story ended there, to wrap the mystery in closure. But space doesn't do endings, it does orbits, cycles that repeat with subtle difference, teaching us that understanding is never a finish line but a revolution. An ellipse of curiosity. 3 Atlas was part of that rhythm now, circling within the same sunlight that sustains us. Somewhere in that motion, between gravity and grace, the line between alien and natural blurred entirely. And maybe that's how it should be, because if the universe truly is one continuous creation, then everything, every comet, every thought, every question is part of the same slow heartbeat. By mid-year, the object's path had carried it into the soft evening quadrant of the sky, a faint echo of motion behind the dust lanes of the Milky Way. The world had grown quieter around its name, but not indifferent. The silence had changed shape. It was no longer the hush of secrecy or fear, but of understanding. As if for once we had learned to coexist with the unknown without needing to cage it in answers. At observatories scattered across the planet, telescopes continued their unhurried watch. The long, pale line of data stretched across weeks and months. Light curves, radar echoes, subtle polarization shifts, all weaving a pattern that looked almost like calm. Nothing sudden, nothing alarming. 3 Atlas simply was. stable, serene, and deeply ordinary in its strangeness. For scientists, the fascination shifted from what is it to why does it endure so perfectly. The models kept failing to explain its stability. Jupiter's tug should have destabilized it long ago. Solar radiation should have altered its albedo. Outgassing, if present at all, should have nudged it into drift. And yet, orbit after orbit, simulation after simulation, it remained immaculate. It behaved as if it understood balance in a way no random fragment could. Some called it a natural miracle, a coincidence of mass, spin, and sunlight so precise that it mimicked control. Others whispered that the word mimic was unnecessary. But the debate no longer carried the weight of confrontation. Both sides had softened, meeting halfway between wonder and humility. In the end, the truth mattered less than the harmony it had brought. In late May, the first test signals from the JUICE mission's relay came through. They had completed a remote pass of 3I Atlas at nearly 200 million kilometers. The readings confirmed what earlier spectra had only hinted at. The outer surface contained a lattice of nickel crystals aligned in near-perfect planes, with microscopic voids suggesting ordered growth or construction. The data were cautious, the language conservative. But buried between the lines was an admission. This object was at the very least organized. Even so, JUICE found no heat source, no engines, no magnetic fields that implied activity. It was both structured and inert, intentional yet asleep. The report closed with a phrase that quickly spread across the world's headlines. An artifact of physics, or of will. We cannot yet distinguish the two. For months after, artists, poets, and musicians adopted that line. You could hear it whispered in galleries and songs on quiet late-night broadcasts like this one. An artifact of physics, or of will. Maybe that's what every star, every living thing, every dream really is. A year after its arrival, 3I Atlas faded into the far side of its orbit, beyond naked eye reach. It no longer dominated headlines, but its presence lingered in the collective pulse of the planet. Space agencies prepared slow missions that would take decades to reach it. Writers folded it into myths. Philosophers used it as proof that wonder itself might be the universe's most stable orbit. And us? We learn to live with the idea that some questions are not meant to resolve but to remain. Quiet anchors that hold our gaze on the infinite. We realize that mystery is not a flaw in our understanding, but the heartbeat of discovery itself. Perhaps 3I Atlas was never here to deliver a message. Perhaps its lesson was silence, because in that silence, we rediscovered listening. Not for signals from beyond, but for the faint whisper of our own curiosity returning to us through the long echo of light. When you step outside on a clear night now, look near the path of Mars, and imagine a small silver thread looping unseen across the dark. It's still there, circling with us under the same gravity, unhurried and eternal. And maybe, just maybe, it's watching back, not with eyes or senses, but with the same gentle patience the universe shows everything it creates. After all, we too are captured travellers, bound to our star, luminous for a while, drifting through deep time, wondering what it all means. And maybe that's enough, to look up, to ask softly, and to keep orbiting our questions until they shine. Now let your thoughts drift the way light drifts across interplanetary dust. Slow, unhurried, quiet. We followed a visitor from another star, watched it cross our skies and settle into our sun's embrace. Some stories end with answers. This one ends with stillness, because the universe, in its wisdom, often keeps its greatest truths wrapped in silence. As you breathe, imagine the rhythm of your own pulse matching the orbit of that distant traveller. Each breath a revolution, each heartbeat a turn around your own small sun. The air around you is ancient, made of atoms that once burned in stars long gone. They've journeyed through darkness, through cold, through time itself, only to become part of you in this quiet moment. Let the vastness shrink until it feels gentle. The same physics that guides galaxies also steadies the rise and fall of your breath. You're made of the same light, bound by the same gravity, held by the same quiet order that keeps worlds from drifting apart. Outside, the night waits patiently, unchanging, eternal. Inside, your thoughts slow, your body settles, your mind loosens its grip. Somewhere above, Thursa Atlas glides through its orbit, carrying the same calm through the deep black sea. You don't need to chase it. You're already part of the same motion. So, rest now beneath this endless sky. Let the mystery watch over you. The universe is vast, but tonight it feels kind.